Hello, everyone. How's your Dreamforce going so far? Not bad? Oh. I know we're all developers. We can do better than that, though. Yeah! Dreamforce is going great. Woo! Heck yeah. All right, so as a fellow developer, I have a strong dislike for PowerPoint slides. So you'll be happy to know I have a very small number of PowerPoint slides and a large amount of demo. So yay. So we have a lot of content to cover today. We have about 40 minutes to do so before I open Q&A. So I'm going to skate through some of the more higher level topics and get right down to the meat. And I will be outside the room for extended Q&A after the session. I'll be there as long as people want to ask me questions. So come on up and say howdy. All right. Right along. So today we're talking about integrations with the Force.com platform using custom Apex REST services. That's a mouthful. All right. What do I mean by that? I'll talk to you about that in a second. A little bit about me. Hello, I'm Andy Betcher. I am Chief Technical Architect at a Salesforce partner up in Minneapolis, Minnesota, Demand Chain Systems. I have been lucky enough to be recognized by you, my wonderful community, to be a Salesforce MVP for the last 4 years. I also co-lead the Minnesota Developer Group with James Lothry as well. And actually, I got 12 Salesforce certifications as of last week. I should have updated this. All right. So, again, overview. As somebody sitting in your seat through many sessions, I want to know what should I walk out of this room for, right? And usually if I don't get this slide, I usually get up and walk out of the room in the first 5 minutes. So I want to get you some facts down. So what you'll be learning, we're going to talk about architecture. What is this pattern I'm talking about? We're actually going to go through and dive into the Apex REST class. What makes it a REST class? What makes it so special? Why am I up here talking about it? We're going to talk about inner classes, or sometimes you heard them as helper classes, and why they're so awesome and integral to this solution. In the rest of the world, Apex REST services have a little thing called REST options as a verb. We don't have options in Apex. So I'm going to show you the heart of the design pattern, which allows us to emulate an options. And then, wait, what about clicks before code? One of our jobs as developers is to honestly work ourselves out of a job, right? There should be no reason why we are 5, 6, 7 years from now maintaining the same piece of code. So everything that we want to write needs to be forward-looking in nature and allow the business to control it as much as we can. So there's a little flavor I'm going to throw in about that. And then summary and recap and QA. All right, what you'll be learning, that this is a standards-based design pattern. It's based on REST and JSON, which are standard as standard can be across the web services arena. And the beauty part of this is, unlike having an external entity use the REST API, I have to teach them how to use SOQL. What's SOQL, right? Ugh. I don't want to teach people that more than I have to, because all they're going to do is use it for the one time and forget it. They're not going to be able to optimize it or learn future things or go back and modify it when I add fields. I want to give them a standard in and a standard out to this design pattern, regardless of when they're coming from. Again, going back to standards. We're going to build forward. We're going to build context-appropriate responses. Using the standard REST API, you get back all kinds of errors, from validation rule errors to you name it. There's a library up on the developer website that's about 18 scrolls long, right? And you don't want the external partner to have to learn that and have to account for all of the different errors that may come back because an admin in your organization or yourself has made a change and it's going to affect their outputs and inputs. Automatic synchronization with object metadata. What we can do is bind our variables to actual S objects. So if we make changes, add fields, delete fields, et cetera, so forth, we don't have to go back into the code to edit that. That's a standard Apex piece. Quick and easy to implement. We put this in. You know, you can get pretty darn verbose and really trick it out. But in all honesty, you're looking at about 150 lines of code, period. And one unit test if we go the flow-based option, which I'll show in a minute. Also, we're enabling the business. I don't want to have to be on standby all the time when the business comes up with the next thing they want to do, right? Because we all know that as soon as we build something, it's perfect, right? No, right? So all of a sudden, sales ops comes back and says, oh, we want our external partner to be able to send us data in this format to do this. Great. I have to go back into my code and make that use case. By extending into flow, we can give them the power to do that. Let your business take the wheel. Again, we're not in this for maintenance. We're in this to build and create and make really cool stuff, right? All right. So, architecture-wise, how does this actually fit together? We have our external system, and we have Salesforce, right? We have to figure out how to get data back and forth. So the first one is we use an Apex inner class to define what a request is. So this request is, and I'll show you the code in a second here, but essentially the request is the same thing. The external entity, I don't care if they're making an account, an opportunity, calling for data, you name it. They have the same object. They just maybe populate different variables, but it's always the same thing going in. We have a REST processor. That's our Apex class. That talks to Salesforce. Salesforce processes what we're going to do with it. The REST processor deals with all the stuff coming out of Salesforce, and I package that into a really neat response object. I don't have changing fields. I have the same variables going out to my external consumer every single time, regardless of success or failure of the actual transaction. Again, going to standardization. I want them to be able to expect stuff. All right. I told you I hate slides. So we're going to dive right into the code sample. All right. So the first thing, we're going to talk about inner classes and the request response. That's really core to this. And come on, laptop, don't fail me now. Resume. OK. So I have Developer Console up, and inside Developer Console, I have a class called WS Web Processor. And I gleaned by it really quick in one of my earlier slides. I have a GitHub out there. It's github.com/techman97, TECHMAN97. All of this code that we're talking about is up on GitHub right now, so you can pull this down right away. So the way we put this thing together is I'm going to go down and go right down to my inner classes down below. I have a global class, and I'm going to shrink that down because we don't need that. I have two inner classes. I have one called request, WS request, and one called WS response. In the example today, in my request, this is what the external system is going to consume and going to send to me. I have an action name. I mentioned in an earlier slide, we don't have the ability to do options. If you really want to kind of stretch this over to the SOAP world, everyone used a WSDL, consumed a WSDL, tells you what the thing can do. Essentially, very loosely, that's what options does in REST. So the action name, we're going to let them tell us what they want to do. And they're going to let us tell them what they want us to do with a contact object and an account object. They're just going to pass the data in and say, I want you to create this or update this or send me an invoice. Or they can basically make any verb you want. I'll show you how we use that above here. And then once it all processes, no matter what, there's try-catch blocks, there's all kinds of things to make sure I catch any potential blip in the code or, because those never happen, right? Who has perfect code in here? I like it. I'm going to pick on you in a little bit. So regardless, I'm going to send back the same 5 pieces. I'm going to send back a status, which is a Boolean. Either it succeeded or it failed, so that the consuming system knows either it succeeded or it failed. They don't have to go scan through a bunch of error codes and guess if they succeeded or failed. I have an error code to follow up. Again, that business-sensitive or business context error coding. I have another map up above, which I'll show you in a second, where I'm just making some arbitrary error codes that make sense to me, means something to me. It doesn't mean anything to Salesforce, because honestly, an external system, what do they care about what the Salesforce error codes are, right? So I'm going to make some context-appropriate ones. I have a message and message detail. Think of it like a subject, or basically a title and a body, or a subject and a body. I'm going to send back something. Maybe I'm going to send back the ID of a record I just created. Maybe I'm going to send back, you name it, in my subject line. In the body of the line, my message detail, I can stick anything again. In this design pattern, I jam in exception stacks into that, so I can go back and debug that as I'm building this thing out. Or I can, you can stick anything you want in there. And requested action is just an affirmation saying, hey, you told me to do this. I'm just telling you that I did this with this data. All right. PowerPoint. Ooh. All right, code sample 2. So how does this actually bind together? I'm going to spin to the top of the class. So in Apex REST land, we can do all the standard verbs minus the options. We can do gets, we can do posts, we can do patches, all the normal REST stuff. In this pattern, I'm using post because I can stick a pretty hefty payload inside of a post. So I have my annotated class and my annotated method of my post. This is called my action router. I'm doing a little bit of assembling, pulling in my request object. I'm assigning my a successful status code to my response. I come in, and here on line 45, I'm going to do a strict deserialization of that incoming JSON string against the request object, the request inner class I have at the bottom of the record. And I like to do, I'm a big fan of planning for garbage in, garbage out, right? I don't want any extraneous information. I don't want them to stick something randomly that they had in their process anyway. I don't want dirty data. So I'm going to do a strict deserialization against that inner class, and if it fails, I pop back a caught message saying, hey, the JSON's not cool. Send me some clean JSON. On 52 and 53, this is the magic of phase one. I have that requested action in my request inner class, and they can pass in create account or update account or really any string you want to define, and all it is an if-then statement to shoot it down to a method down below. Super simple, right? If I spin down here to the create account, again, pretty straightforward. I check for required data. If you didn't send me an account, how am I supposed to insert that, right? So I check for that. If it's not in there, I shoot back a response, and I have a process response method that just collects stuff together. I send it back with a false, which is my result code, saying, nope, didn't work. I have a 1002 error code, which I have expressed as a missing data error message back to the consumer. An affirmation of the action name. I slide down here to my try catch. This is pretty straightforward DML stuff. I'm going to make an account object based on that on the data they sent in. I'm going to insert it. I'm going to grab the ID, jam it back in my message, set my flag that I process things to true, and I have a catch at the bottom. Now, as you all know, there's many, many, many different ways to catch an exception. I just have a very generic catch-all at the bottom that I assign a random error code to, and then send that back out. Update account's the same type of thing. Looks very, very, very close. You could probably factor that a little better, but update account's the same way. All right. So, code demo. I want to put it all together. What does all this crazy spaghetti code actually do? So here we have good old Salesforce Classic. I'm going to rebel a bit and not show it in Lightning Experience. I'm just, rebel in me. Anyway, sorry. Has anybody heard of Workbench? Awesome. For those of you who did not raise your hand, Workbench is going to be one of your favorite tools walking out of this session. Why? Workbench allows me to do all kinds of fun stuff. I can query, I can use REST Explorer, I can attach to any REST endpoint inside my org. I can do all kinds of fun stuff. So in here, I have selected the REST Explorer. Now I have jammed my REST endpoint up into the top there. Services Apex REST Web Processor. The Services Apex REST is the root URL for all Apex REST web services in your org. And the web processor end comes off of what you define at the top of your class. In your URL mapping at the top here, that just says where I'm going. Now, if I open this thing up, my apologies, I did not zoom this properly before I came here. There we go. Can you guys read that? Yay? Anybody know? Rock and roll. Okay. So I have a JSON string in here. This is a JSON representation of my inner class, the WS request inner class that I have at the bottom of my WS web processor Apex class. I have an action name. I'm telling it I need to create an account. And I have an OBJ account where I'm just passing in the API names of all the fields and the values of those fields that I want to set. I go ahead and execute that, and I get logged out. Yay, demo gods are with me today. All right, so you get to see this in action. I flip it to post, you open up the cheat sheet, you grab the endpoint, jam it in there, and I'm going to grab the little JSON representation here, bloop, 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 paste that in there and make my box just a little bit bigger so you can read it. All right, take two. So we go ahead and execute this guy. We load. And down below is a visual representation of my WS response interclass that I have processed, assembled, and sent back to the consumer. You'll see I have 5 things, period. Status true, woohoo, I succeeded. The requested action, you told me to create an account. I'm just affirming that I did a create account action. Message detail, in my create account method in the Apex class, I take the ID I've inserted and I just jam it right in, just so they can consume it without making an additional call or wait for an ETL role just to come across. I have error code and message. I have a map inside that class that keeps my business sensitive or contextually sensitive error codes and responses, and I just pop that back into the response. Now, to show you something about, say I don't do a name, right? To show error handling, to show how it's different, right? Or how it's not different, how it should not be different. We all know that name is required when inserting an account, right? Because why else would you insert an account? You may have validation rules, you may have triggers that fire on things, all the normal stuff that you do that you know because of the beauty of the Salesforce platform, it all gets wrapped in, we don't have to account for it, it just happens. If I execute this guy, it has failed, I have caught that failure, and I've modified, again, the same 5 things going back out. So the calling system or the consuming system does not have to change the way that they consume my response based on successes or failures or anything. False, it did not work this time. I tried to create an account. What happened? I just take the DML action and just jam it right into the message detail so they can see that, and then I have my error code message at the bottom. All right. Okay, now comes the fun part that I did not include in the description for this. Time to blow your minds. So I talked about earlier, you may be thinking, well, he talked about clicks before code and this flow thing, but he didn't talk about a thing about that yet. Well, I saved the best for last. This is pretty slick. So again, leverage the platform. You should always, whenever you're developing, you're always working clicks before code. Let the platform work for you. Do not reinvent what the platform does for you. This pattern, technically, you're reinventing a little bit, right? You're already reinventing the standard REST API, but for good reason, in this case. For just creating an account, Flow does that. And what's the best thing about Flow? I don't get the call at 2 a.m. when sales ops has decided to change the way they do things at month end and are scrambling because the API is not working the way they want it to work. And they thought they emailed you, but they didn't, right? Or you emailed it and forgot about it. And either way, that's never happened to me ever, no. So again, clicks before code. Why lock yourself into all? Should be ongoing maintenance. Again, we as developers, our job should be to work ourselves out of a job. We need to be able to continually enhance and provide cool functionality to our user base, not maintain what's there. If we maintain, we become a dirty word. If we create, people love us, right? It's until it breaks. Breaks or they have to come back to us time and time again to fix stuff. So provide the framework. We can take the same framework I talked about, jam a flow right in the middle of it, and all we care about then as developers is the ins and the outs, similar to how our consuming platform only cares about the ins and the outs, right? We make ourselves a middleman or a man in the middle to this thing. We let the users grow the use cases. Now, I hear the grumbling. That's a double-edged sword, right? Letting our users control the use cases in an API. So again, training, follow-up, training, alcohol training. And then let's move our business logic to Flow. So our Flow demo, again, to reiterate, why the power of Flow versus our Apex code. At the end of the day, from an actual end-of-day standpoint, we're still inserting accounts either way we look at it. But the first one is static. Apex code is static. It's maintained by you. You extend a rollback, you have to do a deployment, right? And depending on the size of your org, I have some orgs that take 5 minutes, I have some orgs that take 50 minutes. The last thing I want is, again, month end, I got sales ops on me to change something, I completely forget something or I copy pasted too fast and I have some actions going to the same method down below and I have another 50-minute deployment to get it back out there. And then we have to have Apex unit tests, right? Our friend Mr. Unit Test. We have to have unit tests for each use case when we come to Apex. Every method that we put in there, we have to express a use case around, or a unit test around. Dynamically through Flow, it's maintained by the business. They can extend and roll back by flow version. So they could be working on a new version of the flow for a month and then activate back and forth for A/B testing. Do it in a sandbox, right? Promote the stuff up. You don't care. Honestly, you don't. And the beauty from a programmatic standpoint, again, we care about the ins and the outs. We only have one Apex unit test. They could add 1,000 different type of things they want to do or use cases. Doesn't matter to us. We have an in and an out. We just provide unit test coverage for that. All right, flow demo. All right, again, demo gods, don't let me down. So I'm on purpose navigating through the interface because as one of my intro slide, I mentioned I co-run the Minnesota developer group, and I'm surprised at the number of developers that don't know about Flow or don't know where it is or don't know when they should use it. So I'm navigating through to show you where it's at here. Flow should be your best friend. All right, we have flows. I'm going to go ahead and open a flow. I've already created the flow. It's called REST Service Business Logic. And again, just as much as the Apex code is in my GitHub, the deployable representation of this flow is also in my GitHub as well if you just want to pull it into your org. Boogity, boogity, boogity. All right. So what I showed you inside Apex, I had the two use cases. I had a create account and update account. I'm just replicating that here. So we have our start node, our decision node here, where we determine our intended action. This is just a decision element. So I have two branches coming out. I have if it's a create account or if it's an update account. If it's a create account, I do a fast create, which just jams the whole object into Salesforce. And assuming it succeeds, I have an assignment where I set my response variables. Again, those 5 response variables I showed you inside of Workbench, I'm just setting those. Same thing for update account. I do a fast update on that account. Assuming it succeeds, I do action success. Now, you may or may not know, honestly, I did not know until I started playing with this, is what if it fails? Most flows that I've ever worked with, I don't think about the fail, right? Until it fails and I get that email in my box at 2 a.m. at month end because SalesOps is data loading 1,000 records, right? So Flow allows you to draw a second line from that diamond at the bottom to another box which indicates a fault condition, which is pretty darn cool, right? And then if anything fails, it falls out to this other assignment where I'm saying, no, it didn't work. And the magic variable that Flow has to capture any stack errors that are happening, I don't care if it's a missing field, I don't care if it's a trigger issue, I don't care what it is, the flow.fault message variable that's built into Flow surfaces that. I can take that and jam it into my response and surface that back to the consuming system. So again, I have the same thing. All right. Let me flip back to my code. Now here's the scary part, because now I have to save to Apex, and I don't know how long this will take. So you may see me tap dance for a minute. All right, so we have our action router post, which is all Apex that I just went through. I'm going to go ahead and comment that out. Everyone take a deep breath with me. Actually, I'm going to have to do a larger one. Right before I came down here, does anybody use Maven's Mate as an IDE? Awesome, awesome platform. Well, it crashed on me right before this thing, so I'm in here. So I have to arrow through a couple pieces here. My apologies. Normally this is just a oh boy. Tab indenting. Exactly. All right. Now that's my little bit of OCD popping there. Okay, cool. All right. Woohoo. All right. So as this thing is saving, I'm going to walk through. So it looks, oh, that was quick. Of course it was. All right. So you're going to see that the method here looks strikingly the same. At the top, I'm pulling in my responses, and starting to construct, I'm pulling in my request, starting to construct my response just like I was before. I'm doing the strictest serialization out to the same WS request interclass. But this is the change, this section right here. Instead of doing the if-then conditions, popping it out to other methods inside my class, I'm going to go ahead and make a map of string and object, and I'm going to take all of those pieces I sent in, all of the, let me say that differently, all of the information that my consuming system is sending to me, I'm going to stick into input-output parameters of my flow, right? And this is how I get it into those. Then I call my flow, I call it flow rest. This is my REST service business logic, passing in my map of parameters. Start them up. It processes. Now, for those of us who have worked with flow, there is a little bit of extra processing time to spin up that flow, right? So as you're going through this pattern, knowing that we're dealing with seconds or very few seconds in an overall transaction, right? It typically adds about 0.2 seconds to the transaction time to spin up flow, just so you know. You just want to plan for that in your landscape. So as it's done processing, I pull out some output variables. So I'm pulling out my success indicator from flow, my error code, any type of other error information, and any extended information I'm going to stick in the message detail. And I'm going to go ahead and send those through to my method where I construct the response, and I return that to the consuming entity. So that's saved. So here's the $1 million try, right? So I go back here, open up my accounts again, new this week. All right, so there's test account 1. That's the one we tested through Apex a minute ago. If I come back in here, I'm not going to change anything in this envelope except for adding the name back in, of course. We want this to succeed. Flow test. I have not changed the endpoint. I've not changed the structure of the JSON. I'm just adding the name back in. Execute that. Look at that. Exact same response, but this is through flow instead of Apex. And he had added about 0.2 seconds onto the execution time. Same status. Same action affirmation, same message detail, same message, and same error code. Similarly, if I come back in, take it back out, same response through flow. But the beauty part with this is now your business is empowered to create their own use cases. You can even do this midstream. If you start with a fully Apex piece just to prove it out and get the endpoints running, you can do a deployment to insert flow, and as you see, they don't have to change anything. You're just changing the guts. Absolutely. Yep. So if I pull all this here, oh, it's going to be silly with me here. Come on. So if I pull this and just go to my favorite JSON editor, JSON editor online, paste that in, make it pretty. That's the raw response coming back out. What was that? Absolutely. You can stick whatever you want, right? Oh, you want, okay. Yeah, I'm not gonna, for the interest of time, I'm not going to show it here, but you can jam whatever you want into those responses. You can add more variables going back in the envelope. You can really do whatever you want. I have some implementations of this in the wild that have 50 input parameters in that from the request interclass because it does so much stuff. I mean, think about it from a, has anybody used the composite API yet? You know, you can chain different pieces together and lower your overall API consumption count. Same type of idea here. Say I want to create an account, 7 contacts, 14 opportunities, 75 activities, and just have list elements in there. I can totally do that, and I control the insertion order, so I can just roll my way through stuff. So your mind kind of starts sparking with ways I can have this in one API call, right? Versus in that previous example, 150 API calls if I use a standard ETL tool like Informatica or something to move that stuff over. All right. Summary and recap. Again, what should be walking away with? Ideas. If my biggest hope for all of you walking out of this room is that this was a really cool design pattern that sparked some really cool ideas for those of you who have integrations, who are thinking of doing something like Informatica Cloud or having a custom rolled web service out there that's going to consume Salesforce and deal with all of that. This is just one great tool, and I've used this enough in the wild where it's proven, it works, it's solid, and it comes completely true to form on the reduction in the API count, which is huge, right? Even though nowadays APIs are relatively cheap to purchase, you still don't want to buy them if you don't need to. Business process focus versus the raw API, you can honestly choose either way, the pure Apex route or the flow injected route. I really like the flow piece, even though it adds a little bit to the transaction time because it allows my business to really work those use cases. We're future-proof and extensible. We're binding to actual S-object variables, so as long as our admins are adding fields, removing fields, handling validation rules, we do not have to emulate that or duplicate that in the code. We just bind to those objects. Leverage the platform, expand adoption. One of the hardest things that we have to deal with as developers is to get people to use what we've built, right? We can have the best requirements documents in the world. We can deliver this spot on and have all the unit tests in the world pass until the users do not use it on day one. By using design patterns like this to pull in declarative pieces of the platform, you are basically requiring the business to interact with the solution and become one with the solution and own and run with the solution. And then the bottom one, I do have my GitHub link in here. So that's my GitHub link again, github.com/techman97. This presentation, as well as all of the metadata behind this and the text file with my cheat stuff, is all up on GitHub. So you can reproduce this entire thing when you get back. And thank you. So, real quick, we have for general Q&A, we have about 8 minutes left in the room. So if you guys would like to, there's a microphone in the center if you'd like to ask some questions. Otherwise, you could just ask them from your seat. I may repeat them back just to make sure the recorder gets them. Question? So the question is, can I directly expose a flow through an API instead of having to wrap it inside of an Apex piece? Yep. You have to have something to invoke it, right? Yeah, you have to have something. You could strip this whole design pattern down and just have one use case with some inputs or at the top of your class and just call the flow. You can strip it down that far. This just allows you to extend it very far. Yep. Anybody else? Does flow support bulkification? Oh, that's a loaded question. So technically, yes, flow supports bulkification. I would urge you to read the documentation to make sure that your use case specifically is covered. Yes. Question? Anybody at the mic? Anybody else? Go ahead. You can, if you set up your interclass, your request in such a way where you're taking lists of things, you could just generate a large JSON string and just paste into Workbench, and that could be your load test. Yeah. I don't believe so. Outside of full-on Salesforce limits on the inbound message size. Yeah. Other questions? Anybody? Oh, go ahead. You go ahead first. Do me a favor. I can't hear you. Can you go to the mic? There's one right in the hole. Okay, so the question is, can I use Process Builder instead of Flow in this design pattern? So you can, kind of. So in this design pattern, I am explicitly invoking that flow. So I could invoke 7 flows if I really wanted to, or have other flows embedded in the flow, like subflows. I could also have process builders attached to the DML actions of a certain object and have that fire. Now, the difference is if anything happens there, I haven't tested this though. If anything happens there, I should be able to get the error surfaced all the way back up, but I'm not 100% sure if that'll work. No, that doesn't. Okay, it just fails. And, all right, well, thank you. So no, you won't get the error message back. It'll just come back with a fail. Yeah, you'll get the email. Yeah. So I think there was a question. Did you? That's the HTTP response code. So 200 is HTTP OK from a raw actual packet standpoint. I can return like 301, 501, different things like that to denote that something is broken inside the web service. I just set it as 200 because I'm covering all of my error conditions inside the code itself.
In this example that you gave, for instance, insertion of an account, can they pass me 200 account records in a single payload and I process them in one single batch?
As long as if you're using the flow piece, I would double check on the documentation to make sure you can process more than 100 in a flow. I believe you can, but yes. I'll always have that caveat to double check your documentation. Oh yeah. No. Yeah, so if you go the straight code route, you could pass 1,000 in. The system's smart enough to chunk that up. Yeah. Yep. Or if it's too big, you can check the length of the string and just truncate it or send something different or say, hey, you really messed up, call me. Yep. Any other questions? Say that again? So this pattern for callouts, it's a yes and a no answer. So the question is, would this pattern work for callouts? If I am not doing a direct DML action, it's the order of operations piece, right? So I can't do, I always mess this up. It's one or the other. Either you can't do callouts before DML or DML before callouts. That rule still applies. So if I am doing like invocable Apex through that flow and I'm doing a callout there and it hits the order of operations there, it'll error and roll all the way back out. But theoretically, yes, it would support callouts in the right order. Anybody else? Question? Go ahead. Say that one more time. My classic answer, yes and no. So, standard out of the box, yes. You absolutely have to OAuth in to be able to access it if you use it standard. Up on my blog, andybetcher.com, I have a long ago post from a couple years ago about how you can take an Apex REST class and expose it via sites and have it be an unauthenticated web service. Now, you're bound to the same restrictions that a guest user account on sites has, so you can't update contacts, you can't update accounts, things like that. But you can absolutely have a public web service through sites with this design pattern, or any Apex REST at all. Can you control, so the question is, can you control permissions based on endpoints? If you write code in either in Flow or in Apex to account for those, you do get things like the remote IP address and whatnot. You can actually, in the request, have your consumers send through a key, a string, something to identify themselves. You can act upon that in any way you'd like to act. But from a Salesforce platform security standpoint, you're coming in with a if you're going through sites unauthenticated, it's the one guest user that goes in, right? But if you are using an OAuth, like a more standard secure piece, you could have people come in with different user accounts and then control access on those profiles behind those user accounts.
So it's within the actual code, it's not, you can't control what endpoint they can hit and which one they can't hit?
So the question is, controlling what endpoint they can or cannot hit. I'm going to say that I'll bet you money that there's enough variables coming in through the response or through the REST request object that comes in that you'd be able to see that, oh, hey, you're coming from this IP address. I'm not going to allow you to go any further and just dump it back out. You can through, let's see here, you could, if you assigned different user accounts to different people who are consuming it, you can use the standard profile IP restrictions to say you can only come from these IPs, and that would just destroy them completely. They get a big old unauthorized access if they try to hit it or try to authenticate at all. But to really answer your question, I would probably express those restrictions in the Apex code up front before I invoked flow or anything else. Yeah. Question? Yep. So and I'll pull it up here and I'll show it. The question was, let's see here. If I can capture it right, and please correct me if I'm wrong. The way I'm structuring and responding with my response is the same as my request from the interclass standpoint. So I have my request down below, my response is up above. I do have a constructor that helps me pull it together, and I have another method that kind of binds it up, so because I'm calling it from a bunch of different places. But all I'm doing is just filling variables, and then I serialize it and send it. Oh, I can customize the heck out of it, yeah. Yeah, nothing in here other than the actual syntactical call of flow is bound to the platform. You can take this 7 ways from Sunday. Anybody else? Go ahead. So so the question is, how does it know? How does it know that account.name that I'm passing in JSON is account.name on the S object? When I'm creating my request, when I'm actually making the interclass, I'm actually making an account instance. And then the deserialized strict will look at the JSON coming in and bump it against that account object, and it maps everything out automatically for you. The beauty of JSON and Apex. It's a beautiful thing. So if there's things like if you pass in a bad field name, a missing field name, anything like that, when you do the deserialized strict, it'll detect that and reject the whole thing out.
If it's on declare right there, at the beginning, that get set, that JSON strict deserialize.
Magic.
But it has to be here.
It has to be here. If you take an approach of making individual variables for every piece of the account, it doesn't work. This enables the magic. Yeah, question? It's on API name. Everything in Apex is API name. Exactly. You can use whatever you want. I just happen to use account because I can type it. Oh, I'm sorry, I'm over on time. All right, thank you all. Again, I'll be in the hall right out front. If you have any other questions, I'll be out there in about 2 minutes as soon as I get unhooked and unwired here. Thanks, guys.